Alright, 527. Penguins. A study of king penguins looked for relationships between how deep the penguins dive to seek food and how long they stay underwater. For all but the shallowest dives, there's a linear relationship that is different for different penguins. The study report gives a scatter plot for one penguin titled "The Relation of Dive Duration (dd) to Depth." Duration (dd) is measured in minutes and depth is measured in meters. The report then says the regression equation for this bird is given by that. Okay, so each penguin is going to have a different scatter plot basically. And so for this one penguin, we've got this situation. Okay. Try to understand what the problem is saying rather than just say, I just need an answer, because that's not what this is about. It's about trying to understand the bigger picture of what's going on. So we've got, for this particular penguin, we've got my equation, the dive duration, and then so I'm going to write it down here. D dive duration is 2.69 plus 0.0138 d, where d is the depth. So this is d, that's the depth, and up here is d for dive duration. And I know this is my x and this is my y. Okay, and I know this is the regression equation, so I'm going to put a hat here because that's my predicted value. And if I try to make a scale on this is a little bit difficult here with all the decimals and things. Okay, this will be jumpy because I just paused and don't know what my last sentence was. But here's so anyway, big picture, we want to look at, this is what we've got. So we've got different depths on here that the penguin went with different dive durations, which is lengths, and this is in meters. And dive duration, reading back through the problem, does it say what units that was? Minutes. So we're going to have different data that looks something like this, and the regression line goes through the middle like that, and we've got our scale that looks something like that. Okay, I don't have the exact data, so I don't know what these values really are, so I can't put numerical values on this axis yet. Okay, so let's go ahead and answer the questions. What is the slope of the regression line? So the slope is the coefficient of my x, so the slope, so a, slope is 0.0138 over 1, and I have to put my units on it. So the units are minutes on the top for my change of y, and meters on the bottom. This is what we talked about on the last video. So it's change of y over change of x for my slope. So explain in specific language, it says on average. For each increase of 1 meter of depth, the duration increases by 0.0138 minutes. Okay, does that make sense? Okay, so for every minute of depth, he goes down, we go up there, the duration goes up by 0.138 minutes. Okay, B. According to the regression line, how long does a typical dive of 200 meters last? Well, the duration would be 2.69 plus 0.0138 times 200, whatever that is. So let's see what we got here. 2.69 plus 0.0138 times 200. oops. Okay, 5.45. Ooh, 5.45. Sorry, I guess that goes away when I click on the screen. 5.45 minutes. That's a crazy long time, but it's a penguin. I guess what would you expect? C. The dives varied from 40 meters to 300 meters in depth. Plot the regression line from 40 to 300. Okay, so I'm going to be a little bit sneaky here and call this 40 to 300. So how can I scale this? If I go 40, 80, oh boy, I'm going to run out here. 120, 160. Yeah, see, that's a bad scale, so I'm going to change my scale to even bigger and go what if I did this? 75, 150, 225, 300, and then 40 is going to be way down here, and we want to go up to 300. It's going to be way up here. It's plotted from 40 to 300, so it's going to look like that, and good enough for a close sketch, although I do want to put my Y markings on here at those two values so we can actually calculate what those are for 40 and 80. And I'm going to show you something a little sneaky here. If I put on my calculator where it says entry, I'm going to go second entry, and it puts the last calculation I just did, and I can go back and overwrite any part of it and just do times 40, so that's going to be 3.4242. And then if I do it again, second entry, which is enter, and I'm going to go back and put 300, so that way I just don't have to type in the whole thing again. 6.83. So this would be, this one up here would be 6.83. That's this. Sorry about the mess in here, trying to keep it all on one page. Okay, there we go. So that's 27.